Why don't I get you started and then I'll run through roll. Remember when we graph cosine, this is A, I said cosine, A cosine bx plus c. By the way, I'm trying to not confuse you. Let me mention the book, the program, the Math Excel help button, Math Excel help button. What's it called? Show me an example. Whoops, I spelled show with an E. Show me an example. It will set the formula up a little different. What it will say that the phase shift, it says the phase shift is regular C over B, positive, normal. I'm doing it a little different, which I think will be easier, so I hope I'm not confusing you. I'm just going to say the phase shift is negative C over B. They're saying it's positive. We're saying the same thing in different ways, like saying one or uno. We're speaking different languages. Math Excel, the way they set it up is they said, in their original setup, they said, hey, we'll just call this minus C. That's what they did. They just said, hey, pretend the original thing is minus C. Now, that sounds weird to say pretend. Like, how do I explain that? So in other words, they're saying, hey, whatever's in front of cosine, that's A. So, I'm the same as them there. Whatever is next to the x, that's B. I'm the same as them there. That's pi over 3 in this case, right? And then they say, because they put a negative in the basic setup, what they're saying, when somebody does a formula in math or science like that, and they put in like a negative C, what they're saying is opposite. You want to start thinking that way as you're moving into higher math now? Negative in front of any letter doesn't necessarily mean negative, it just means opposite. Do you know what I mean? Let me make sure that's clear. If I say, hey, negative C, well, is that negative? Well, if C, remember, I don't know what C is. C is a variable, huh? What if C happens to be negative 3? Then that's negative 3. That's actually positive 3, isn't it? So don't think a negative in front of a letter automatically means negative. It doesn't. It means opposite, huh, of whatever C is. So therefore, if somebody gives a formula, if somebody says, okay, I'm going to give you, 2 cosine 3x minus 7. I'm saying this is A, this is B, and I'm just going straight because I think it's easier for you. I'm just saying, look, that's C. So in my nomenclature, my way of calling things, C would be negative 7. Math Excel is saying, look, we're, same formula, right? I mean, same original function. They're saying this is A, this is B, and this is minus C. What they're saying is let C be the opposite of whatever's there. That's what they're saying when they say the general formula is A cosine bx minus C. They're saying opposite of C. I found that's confusing for students over the years, and so I'm just saying, look, it's just normal C. But then in my phase shift formula, I have to use the opposite of C because I called it normal originally. All right, that probably just confused you more than ever. So hopefully not. So come see me. I'd be glad to talk to you more about that. Long story short, don't be confused when you see Math Excel say it's this. They're just doing it a different way. For us, just use the phase shift as negative C over B, right? And the period. What was the period?
2 pi over.
Good memory, 2 pi over B. You can put that on your 3x5 card. Definitely should for the next exam. Anyway, so go forward from there. Go ahead and do that. What is C? On our particular example, what is C? C is just 0, isn't it? There's nothing added or subtracted after the x. It's plus 0. So it's really a moot point in our example, isn't it? So anyway, go ahead. So we got the period and the phase shift. So the phase shift is going to be 0 or negative 0, whatever, same thing, over b, which is pi over 3. But 0 in the top fraction is just 0, huh? So the phase shift is just 0 because C is 0. You guys with me right here? C is 0 because there's no number added or subtracted after the x. That's always C. C is 0, so phase shift, which is C over B, has a 0 on the top, it's just 0. The period, 2 pi over B, and B is pi over 3 like that. So grab that and flip it up, right? Whenever we have a fraction on the bottom of a fraction, 2 pi times 3 over pi, right? It flips upside down like that. Oh, by the way, so I don't go over the exams in class just because I want to use our time the best way possible, and we've been over all those problems before, but I'm glad to go over yours individually. Come by, see me, grab me after class. Be glad to do that. I'm just not going to do it as a big group because we got new stuff to do, and we've done all those problems. So anyway, so now 2 pi times 3 over pi, put this over 1 like that. Cancel the pi's, right? Because whenever a whole number is interacting with the fraction, you put it over 1, make it look like a fraction. Cross cancel the pi's, so it's 2 times 3 is 6. So the period is 6, the phase shift is 0. Period is 6, the phase shift is 0. So what does that mean then about the graph? Well, it's a cosine graph. It's not a sine. So remember, the first half of this homework section is all sine graphs, and the second half is all cosine graphs. What's the difference between a sine graph and a cosine? Let me do them both real quick. So a sine graph, where does the sine graph start? It's all the starting, huh? Yeah, right at 0, 0 in the origin, yeah. Goes up and down by 2 pi's. Period's 2 pi, just keeps repeating himself every 2 pi, his cycle. Right, that's sine. You guys know that. And cosine, where does cosine? He starts high instead of at 0, 0, doesn't he? He starts at his peak, he starts off, and he goes down and back to his peak by 2 pi. His period, his cycle is also 2 pi. So, yeah, that's the only difference. Cosine starts high, ends high, almost looks like kind of a funny U. And sine starts at 0, ends at 0. But they're the same thing. They're just a shift from each other. They're just a 90-degree shift, aren't they? Cosine, remember we talked about co as part of complementary angles. It's 90-degree shift. So they're the same thing. They're just a shift. So the period the period is 6, and the phase shift. Now the phase shift means the start, doesn't it? Whenever we're finding phase shift, we're finding where the thing starts. That's what phase shift means. So it starts at 0, and 6 is the period. So it starts at 0, and 6 is the period. So what does that mean? When I draw this graph, I'm going to start at 0, and I'm going to end at 6. Now actually, it's not going to be, it's going to be up here, isn't it? I'm not doing that right, and then up here. So it's going to, well, this is not right, but it's almost right. What does that mean? It's wrong. But anyway, let me do it wrong first, and then I'll do it right. So at first, and you probably already all know the right answer, but at first we might think it starts high, finishes high at 0 and 6, like that, almost, except why is that actually not quite right? Because of that A being negative. What does that amplitude negative do to any graph? Flips it upside down. Because yeah, I'll just leave it at that. So that flips it upside down, doesn't it? So it's going to take this thing, oh, no, okay, instead of starting high and ending high, flip it upside down. It's going to start low, end low, like that. And how high and how low does it go? Well, the amplitude is a half, so it goes up to a height of half and down to negative a half, doesn't it? But it's upside down because of that negative amplitude in the front. That always turns a sine or cosine graph upside down. So there's one period, and once you have one period, I think you can do the multiple. Test will be multiple choice, just grab the one that matches. This thing, I don't know what they want. They probably, well, here we can look. Has everybody got that down okay? So 0, see how I did that right? Starts at 0, period is 6. The amplitude negative means it's upside down. So the one more time. So this is the negative 1/2 amplitude. That's a vertical flip because of the negative. Vertical flip over or across the x-axis. You see what I mean? Because if you take this as the x-axis, and that's a flip across the x-axis, acting like you grab the x-axis like a barbecue rotisserie and turn it, right? It's like I turned the x-axis. You see what I mean? And that made the graph flip. So that's a reflection across the x-axis is the language they use. Test will be multiple choice. You just grab that one. Our stuff that we did was, of course, you probably weren't thinking a lot about it. You were focused on the test, which was right to do. So, yeah, let's take a look. So this one is y equals minus 5 cosine of 4x minus 2 pi. Okay, so go ahead and go through the different things. They want the amplitude and the period and the phase shift. See if you can find those, and then make a little, one period graph. So these are yellow and blue. Anybody else need the yellow and blue test? If you guys could kind of pass that forward to them, that'd be great. Thank you. Okay, so how you doing? Now, what's the amplitude? It's not -5. They want the positive version of it, huh? They want you to say 5. So just like distance, we only say positive. Period is 2 pi over b. And by that, we mean this is A, this is B, this is C. So 2 pi over b, 2 pi over 4. Reduce that, that's pi over 2, right? Just reduce that fraction. 2 goes into 4 2 times. Period's pi over 2. Okay, now the phase shift is negative c over b. So it's negative. What is c? It's this whole thing, negative 2 pi. So it's negative 2 pi, which will be positive, right, as you know, over b, which is 4. Everybody seeing that so far? Right? So this is the way I do the formula. The Math Excel does it reverse. In the end, it's the same, we're going to get the same answer. So negative c over b, negative, and then c is negative 2 pi over b. So that's positive pi over 2. Period and phase shift are the same, actually. Everybody okay with that? See what happened there? So we got the amplitude, the period, and the phase shift. So can you use those now to put on a graph? Just do a one cycle graph. Up there. So remember, the phase shift is where the graph starts, and the period is how much you add to that to complete the first cycle. Right? So we start, whoops, that's not the start. We start, I mean, it's the same, but we start at pi over 2, positive pi over 2. So that means you go over here to the right to positive pi over 2. Well, let me not put a dot there yet. You go over to positive pi over 2. That's where you're going to start the cosine graph. And is this graph going to start high or start low? Cosine never starts at 0, does he? Cosine never starts. Sine starts at 0 and ends at 0. Cosine starts high and ends high, or if it's upside down, low and ends low. Right? Which one's this? High, high, or low, low? Yeah, because of the negative number in front, negative amplitude, kind of, I mean, whatever you want to call that. That negative number in the front, that means it's going to be upside down cosine. So instead of starting high and ending high, it's going to start low and end low and do this kind of a thing, isn't it? It's not very good drawing, but you get the idea. Right? It's going to be the upside down kind of U. It's going to start at pi over 2. It starts right here. And that's at a height of -5 and goes up to a height of +5. And how far over here is the ending going to be, the end of the first cycle? Well, pi over 2 added to the original, right? Because pi over, that means you add pi over 2, you add the period. So if you take, to find the end, you take the start, pi over 2, and you add the period, because the period is how wide is one cycle, right? So you add another pi over 2. So to find the end, let me write it this way. To find the end will equal where you started, pi over 2, and then how wide a period is, which in this case is also pi over 2. So add those up, 1 pi over 2 and 1 pi over 2 is 2 pi over 2, which is just pi. So it'll end at pi. Half a pi and half a pi is a whole pi, right? Is that making sense? Is that okay? Everybody see? So there it is. There's one side, which is good enough to grab the multiple choice answer and do the Math Excel thing. Let me go over that one more time. So again, we find the amplitude, period, and the phase shift with the little formulas. And then the graph starts at the phase shift. Because the phase shift means the shift of, the original, all these graphs originally start at 0 if you don't have any shift information. But the shift means how far the graph has been moved. So the graph has been moved. It no longer starts at 0. Now it starts at pi over 2. That's what the phase shift is. That's your start. And then once you have that, you add the period, because that's how wide is one cycle. So we added another pi over 2. So it ends at pi. That's where it ends. Its first cycle. Good on that? And it's upside down because of the negative. Cosine, again, always starts high, ends high. Starts high, ends high, or it's upside down, low to low. Sine starts at 0, ends at 0. All right, I think you've got it. Yeah, watch with me, guys, on this. This is tricky, and I don't want you to be tricked. So there is a difference between this, which they're giving me right here, and let me do two things at once. Maybe that'd be the best way to make it clear. And over here in the black, I'll put sine of x plus 4 in parentheses. Those are really very, very different. Those graphs will look really different. Let me help with why. What are we talking about? Well, the way I normally write the formula is I go a sine and then parentheses bx plus c. Right? And let me just leave it at that. So in other words, on the a is 1. No surprise. A is 1. What B is also 1, right? Everybody with me on that? There's no number. Same thing over here. A is 1 because there's really a 1 in front of the sine. There's a 1 in front of the x, so that's our B. That's 1. But here, this is C, and here, this is not C. C equals 0 here. What is that for then? It's going to move the graph up 4. It has nothing to do with the right-left phase shift. When the 4 is outside the parentheses, it's just an up-down sliding. It's a vertical. I'll just say up 4. It just moves the whole graph up 4 instead of right or left movement. It's not a horizontal phase shift. Everybody see that? Whereas this one over here would be, right? That one would move the graph right or left. We'd have to, because we have a C value. So everybody seeing that difference? Let me write it clearly. When C is in the parentheses, it is a phase shift sideways, horizontal, right? But when the number, I won't call it C because it's not technically C. When the number is outside the parentheses, it is not C and it's not a phase shift. It's not, let me just say it is not C and it is up for positive, down for negative. It's just a movement up or down. Can you read that? Up for positive, down for negative. Up for positive, down for negative. So numbers added or subtracted outside the parentheses are moving the whole graph up or down. Not stretching it. That's a little different. I'm not saying it goes higher and lower. No. That means the midline is no longer going to be the x-axis. The whole thing is going to move up 4. That's the difference. When we have numbers added outside parentheses like that, it's going to move the whole graph up for positive, down for negative. So, okay. So if you've got that down, let me come over here and draw a quick little graph. So, okay, so it's going to be a sine graph. Let me try this again. I need room a little bit. Okay, it's a sine graph, and but probably the first thing you should do is go, oh, that plus 4 right there is outside of parentheses. So it's going to take the midline, and you guys know what I mean by midline. Sine normally is like that, right? And his middle is normally the x-axis. That normally spears right through the middle of a normal sine function, right? That's normally what we have. Well, the midline is going to go up 4. 1, 2, 3, 4. So I'll just put a dotted. You don't have to, but I think it might be helpful. Dotted line up there at 4. That's now the midline. So the sine will start. He will end. He'll go above and below that line. The 4. The 4 is the new midline. It's gone from 0 being the midline to up 4. So the whole graph has moved up 4. Everybody see that?
What do you call that? Do you call it a vertical?
It's a vertical phase shift, is what it technically is, yeah. It's a vertical phase shift. So I've been using the word phase shift kind of casually, but there's technically horizontal shifts, phase shifts, and vertical phase shifts. That's a vertical phase shift. Yeah, the whole graph went up 4, so the midline went from being 0 height to 4 height, is the middle, right? Now, the sine, remember, always goes above his middle by 1 and below his middle by 1, unless he's got some other amplitude. This one's amplitude is just 1, so it'll go up to 5, down to 3, even though my graph looks more dramatic than that. That's really what he's going to do. Let me draw him better to fit reality. He'll hit 0 in the middle, he'll go up to 5 and down, down to 3 and back. How do I know that? Well, because the amplitude is 1. Remember, amplitude is how far sine or cosine goes above and below his midline. That's what amplitude is. Everybody with me on that? If this amplitude was 2, if A was 2, then the middle being 4, he would go up to 6, down 2 below 4, down to 2, for example, right? You guys getting the idea? So the midline is 4. This moved the midline up 4, and the amplitude is 1, going above and below the 4 by 1. And this one, I think his period's just 2 pi, isn't it? The period on this one, everything else is normal, is 2 pi over b. The b is just 1, so it's just 2 pi over 1. It's just 2 pi, so there it is, yeah, 0 to 2 pi. Phase shift. What the phase shift on this one, let me get rid of all this stuff. The phase shift on this one's just 0, isn't it? The sideways phase shift, I mean. What we normally call the phase shift. The phase shift being negative c over b. C is 0 over b, which is 1, is just 0. So that's why he starts at 0. So everybody with me on that? So watch for those numbers outside parentheses. Put that in your 3x5 card for the exam in 2 weeks. That 4 is outside the parentheses, so it's a vertical effect. It's not C. C is only inside the parentheses. Questions? Is that good? Well, let's see what they do on math. I like these. These are valuable questions. It's an important section. This is not easy stuff. So let's try that. That plus 3 there, is that in the parentheses? No. So what's that plus 3 going to do? Going to move the graph up 3. So then what is C on this graph? You know, the ABC thing? What is C? 0. There is no C, huh? There's no other number in the parentheses added. Right? Because remember the format. It's A, sine or cosine, same thing, of bx plus c in the parentheses. And then any number out here is the vertical shift, if any number's outside parentheses. You could call it D if you wanted to. I don't think they do anything formal. But anyway, in this one, you know, we have 5 sine. We don't have parentheses, so it's just a half x, and then there's this 3, which is a vertical. So C is really 0. So go ahead, give that a try then. Your C is 0. The 3 is a vertical shift number because it's not in the parentheses. What that means is it's not plugged into the sine function. It's added afterwards. Like if you're doing it on your calculator or something, that 3 is not plugged into the toaster, so to speak. It's not plugged in. It's not the sine of that 3. It's just the sine of the half x. The 3 doesn't get plugged into the sine function. It's added afterwards. In other words, you could just put that 3 in the front, in other words. It's the same as, maybe that'd be a better way to say it. It's the same as that 3 just being in the front. That's what that means, really. When it's not in the parentheses, it's not in the sine function or cosine or whatever. You know, it's added after or outside or front if you want. It's separate. So try to get the graph. Get one cycle on that graph. Give you just a second, and I'll jump in. Okay, so we're doing good here. Let me jump in and help. So 5 is, as you know, is our amplitude. It's our amplitude. Our period 2 pi over b. So 2 pi over, and the b is a half. There's a b here. B is a half. So you know what you flip that half up, becomes 2 over 1 like that. Good. Just grab that thing and flip it up. And whenever you have a whole number or whole whatever this is interacting with a fraction, put it over 1. And so they just multiply, don't they? 2 pi times 2. Just going to be 4 pi for the period on that. Not good. Phase shift's just going to be 0. You don't have to write it out if you can already see that. Phase shift negative c over b is the formula we always use. Kind of getting scribbly there. So negative c over b. What is c? C again is 0, isn't it? Because there's nothing else in the parentheses. Negative 0 over b, b is a half, whatever. 0 on the top is just 0. Negative 0 is just 0. So the phase shift is 0, which means it starts at 0. So now I go to draw this, and this is a sine graph, yeah. So I'm going to start, this is the start, the phase shift is always the start. I'm going to start at 0. The period is 4 pi, so I'm going to, whoops, not 2. I'm going to finish at 4 pi, huh? So basically this graph is going from 0 to 4 pi, isn't it? I got the width, I got one cycle, that's its first cycle. Am I going too quick? Is that making sense? So the phase shift is where it starts. And then you add the period to that. Add 4 pi. That's where it ends. Its first cycle. So the first cycle is going to go from 0 to 4 pi. Now, the plus 3 is a vertical shift up 3. 1, 2, 3. That's going to be his new midline, isn't it? Instead of the x-axis, it's going to go up 3. That's the new midline. And what will it do on that midline? It'll start. It'll end, it'll even hit there halfway through, won't it? And it'll go above it and below it. This is 3. It'll go above it and below it. Are we good so far? Right? Sine always starts at 0, hits 0 halfway through, and ends at 0. Well, not 0. It's midline, whatever its midline is. In this case, it's 3 because of the plus 3. Okay, and this is the height of 0, right? It moved it up 3. Now, what's it going to do? What's the amplitude? 5. So that means it's going to go above and below its midline by 5, isn't it? So it's going to go up here 5 and down here 5. So if you take 3 and add 5, 4, 5, 6, 7, 8, you're at 8. And you take 3 and subtract 5, boom, 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 0, and negative 2, huh? Boom, boom. So it's going to go from negative 2 to positive 8. So if you want, this helps. Here's the window in which the thing's going to do its first cycle, huh? You with me on that? So what's it going to do? It's going to start at 0, go up, whoops, it's going to be back at 0. It's going to be very tall and thin. It's going to go up like this, come back down to 0, down like this, come back up like that. Everybody see that? Yeah.
Why does it end at negative 2?
One more time?
Why does it end at negative 2?
Oh, come down to, yeah, good question. Yeah, because that is the crucial question. So, yeah, so the midline was 3. And let me go over that one more time. That's a good question. So the vertical shift was 3, again. So that means, the middle went from a height of 0 to up 3. Boom, put that down as my midline. And then I need to know how far above 3 and below 3 it goes. Well, that's the amplitude. The amplitude is 5, so that means you got to take 3, add 5, that's up to 8, and take 3, subtract 5. 3 minus 5? Negative 2, huh? So it goes above by, the midline's 3, add 5, subtract 5. So you always add and subtract the amplitude from the midline. Add 5 and subtract 5 from 3. That gives you the top and the bottom. It goes up 5 and down 5 from the 3. So up to 8 and down to negative 2. Sine always starts at 0, hits 0 in the middle, ends at 0. So there it is. Is that good? It's all because that 3 is outside the parentheses. Makes a huge difference, doesn't it? Whether that number's in the parentheses, because then it's plugged into sine, or outside the parentheses, it's not in the sine. We're doing good? All right, not simple stuff on all that. This actually is very proud. This is what engineers do. So if they want to model something in the real world, they see they're building a dam and they see the water rise and fall in a certain cycle based on the river levels and the, then but they need to calculate things and they got to have engines that are going to pull things and do things with that water. I'm just throwing out one of a million examples. They got to program it, and how they can do it? They got to make a function that'll predict the high and the low in the cycle. What's that? Well, that's trig. That's why we made up trig. Remember, math is made up to describe things that are real. So they made up trig, but they would need to have, it goes this high, it goes that low, what its high and low is, what its cycle is, and they would set up a program that would run the engine accordingly. They would need all this to do that. That's exactly what it would be for. They always have a little extra twist. Okay, so y equals negative cosine 2 pi x plus 4. Is that 4 in the parentheses? Obviously not. So what does that mean that plus 4 is going to do, since it's outside the parentheses? It's going to be a vertical shift again, huh? It's going to take the midline from 0 up to 4, isn't it? Yeah.
So we will eventually have questions where it has phase shift and vertical shift. We'll have both of them in it, like A,
Yeah. I'm not sure. We'll see. I'm with you. I'm not sure. We have 4 more questions?
No,
It's certainly possible.
No, I finished them, but like something in the future, maybe like
Oh.
other chapters where we have A, B, C, D on it, or maybe
In the real world, absolutely possible. Does our book actually go there? I'm not sure. Not sure. We'll see. But yeah, and I won't go wherever the book doesn't go. But yeah, it's certainly possible to have all those kind of shifts in one deal. I'm not sure if they'll push us quite that hard. They might wait till pre-calc to push that hard. We'll see. So try that one. Find the amplitude, period, and phase shift, and the vertical shift. See if you can get one cycle in the graph. Remember, cosine starts high inside or starts low inside. Feel free to compare with those around you. Give you just a second. I'll jump in. Doing okay. So the amplitude technically is 7 because they want, they only want the positive, but we know it's upside down, huh? That negative 7 is going to flip it upside down. The amplitude's technically 7. They don't ask. They just want the graph. All right, so I'm just going to jump into the graph. So this is A. This is B. B is 2 pi. This is out here is not. I'll just call it not C. Right. That plus 4 is not C. So C must be 0. So the period is 2 pi over B. So that's 2 pi over 2 pi. Period's just 1. What's phase shift going to be? 0 because C is 0, huh? It's negative C over B. Negative C over B. So it's negative 0 over whatever B is, 2 pi. It's just 0. Okay, so good. So we've got that. Now let's go to the actual graph. And then the plus 4 means move the graph up 4, as we know. Okay, let's try that. So here's the 0. Let's move it up for 1, 2, 3, 4. So at up 4 is the new midline. Is that good? So that's the new midline. Now, how far above... how the graph is going to go above that and below that, as the sine and cosine always do. So how far above and below the 4 is it going to go? 7. That's that 7, huh? It's going to go above and below the 4 by 7. So I need to add 7 and subtract 7 from that 4. Is that making sense how I always do that? So whatever the new midline is, that vertical shift, than whatever the amplitude is. Don't worry about the negative. That just means it's going to be upside down, but it's still going to go above and below. So might as well do both of those right now. By 7. Above and below the middle. So you add 7, you're up at 11. 5, 6, 7, 8, 9, 10, 11. So there's the top, 11. And subtract, 4 minus 7 is negative 3. 1, 2, 3. Negative 3. So I go up to 11, down to negative 3. Again, I got that by 4. Add 7 and subtract 7. Everybody with me on that? So I took the 4, the midline of 4, the vertical shift of 4. And then I add 7, subtract 7, because that's the amplitude. Okay. Now I want to draw, and the period is 1, so that means it starts at 0. So it'll start here at 0, it'll end at 1. So from 0 to 1, it's going to do its thing. It's going to do one cycle. Right? Now what does, this is cosine, huh? Cosine starts high, ends high, or low, low. And in our case, negative amplitude, low, low. Right? Low, low. So come over here, it's going to start low, end low. It's going to start and end at its negative 3, isn't it? Halfway through, it's going to hit the top, its peak up here. Halfway through, so it's going to go like that. There's the basic graph between 0 and 1. Everybody see that? See how I came up with that? Midline is 4. Add 7, subtract 7, because that's the amplitude. Period is, it starts at 0, period is 1. And since it's upside down, it starts at the bottom, ends at the bottom. And it's a cosine. All good? Just takes practice, huh? I think you know all these facts, just remember them all and practice them. Questions I can answer? We're getting close to wrapping this. What an engineer would really do is this direction, the backwards direction, because they would see something in the real world, like the water at the dam site rising and falling. I just recently visited a dam over a summer break. My wife and I took a trip, so it's probably on my mind. We saw, what's the dam by Las Vegas? What's it called? Hoover Dam. Yeah, thanks. Sorry. Yeah. Anyway, yeah, Hoover Dam. So anyway, very interesting how they built that whole thing. Anyway, so I'm sure that's what's on my mind. So as it rises and falls, so they would have something real like this. They would have, look, it rises and falls, da da da. Now I need to make up a function that fits that reality I've seen in the real world. That's more like actually the direction an engineer would typically work. So they see this in the real world, and they go, okay, I need to write a function. See down here they want either y equals a sine or a sine bx or a cosine bx that will fit that reality. Okay, so how do you do it? Let me help. You want to focus on one cycle. Start here at 0. Now, how do you know you start at 0? They don't have any c. Notice both examples, they want me to, the format they want me to fit doesn't have any c, which means c is 0. So start at 0. And it looks like it's going to end about, well, it actually ends right there, doesn't it? That's one cycle right there, isn't it? This one's a cosine. Everybody see that? How do you know that? How do you know I'm going to use the cosine on this one and not the sine? Because it starts high. Remember, sine starts at 0 and ends at 0, doesn't he? One cycle. This graph starts high, so he's cosine. Now you might be thinking, yeah, but couldn't we just say it's sine with a shift? You're right. You totally could. Because sine and cosine are, any up and down graph like this could be written as sine or cosine with just one of them having a shift. That's true. That's true. But let's make life as easy as possible. Let's avoid the whole shift thing, which is exactly what they're saying with the templates, the formats they give us. See, there's no C. So they're saying, hey, write it without a shift. That's what they're saying. So if I'm going to write this without a shift, with no C, then I got to start at 0. And if you're going to start at 0, well, then this is cosine, because he starts high. He doesn't start at the origin, does he? So it's a cosine. You with me? You guys give me the poker face. I just keep talking and talking until I see some, either way, then I know I need to explain more or less. All right, so that's a cosine. So we're going to start high and end. Now, why did I do here? Instead, why didn't I go like further down here or something? Well, because cosine starts high, ends high. I'm not going to stop at 0. So this must be one cycle of the cosine right there. That makes sense? That's one cycle of the cosine. So I'm going to write y equals a cosine bx. So how do we find the a and the b? Well, what can you tell what the a is? The a is amplitude, how far above and below the midline it goes. Yeah, it looks like it's hitting at 3 and then down to an a3. So the a must be 3. That must be 3, so let's put that in. So we've got 3 cosine bx. All we need is the b now. All we need is b. How do we find the b? Well, you remember period is 2 pi over b, right? So it's going to be kind of backwards. We're actually going to be solving for b. What is the period? On this, looking at this picture, don't let any of this bug you. Don't let this bug you. Just focus on this one cycle right here, because period is the width of one cycle. So what is it?
Pi.
Just pi. Yeah, it starts at 0, ends one cycle at pi. Period is pi. So what does that mean? That period is, I put in the period, it's like a little formula, and I just plug in for the word period, pi, because that's what the period is, huh? And then I solve this little equation for the b. Does that make sense? Maybe you can just look at it and solve it. What does b have to be so that this all becomes equal to pi? Yeah, it's got to be 2, because then the 2's will cancel. But anyway, I'll do it formally as well. But sometimes you can just look at it and go, b's 2. B's clearly 2. Great. Save some time. If you can do that, great. I'll do it formally now as well. Formally, to solve for b, whenever you have a little equation, does everybody see how I got to this equation first off, right? I just wrote our formula we always use for b. Period is 2 pi over b. And I just looked at the graph and said, oh, there's the period. The period is one cycle. And what's the period? It's clearly pi right there. Right? That's the width of one U-shape. So that's what you got to do. When you look at these graphs, you got to be able to kind of tunnel vision and get the rest of the stuff out of your view and just focus on one cycle and go, oh, pi, period's pi. So, okay, so how do you solve for b? When you have fractions, you multiply by the denominator, huh? That's how you always handle that. These cancel. On this side is over 1, right? The other side, pi b is what? What's left? 2 pi. Now we can finish solving for b. We already know the answer. Divide by pi, sure enough, there it is, b is 2, as we already knew. So b is 2. So the answer to this question is 3 cosine 2x. That's the function that we're seeing there. So we just took something in the real world, well, it's not real world, but, we could have been something that's modeled in the real world, and say, oh, that 3 cosine 2x would make that exact up and down fit perfectly. 3 cosine 2x. That's what they do with this stuff. Questions on that one? Not good? All right, I'll move on if you've got that down. All right, so try that one. So same thing, they want you to, write a formula, a cosine bx or a sine bx. Give it a try. So first thing is to decide sine or cosine. Look at where it starts. Put a dot where it starts, and I mean at 0, at the middle line, at 0 line. Put a dot, and ask yourself: is it starting high, ending high, or is it starting at 0? How's it start? That'll tell you whether to do sine or cosine. So it starts right here, huh? So sine or cosine? Sine, huh? It's starting at 0. So it starts at 0, so I'm going to use sine. Whereas the last one started, if you look back, see how this one started high. And by start, I mean, at x equals 0. Right? That one started high, so it was cosine. This one starts at 0, so it's sine. So if it starts at 0, it's sine. If it starts high or low, it's cosine. High is normal cosine, low would be negative cosine. Right, so this is sine. Okay, so I'm going to do that. First off, I'm going to use y equals a sine bx. I should say it's sine without any phase shift. You could make it a cosine with some fancy shift, but we don't want to do that. Let's just make it a sine graph with no shift. So find the A and find the B, and you're done. So you got to do tunnel vision, right? You got to focus on just one cycle. Cut everything else out of your vision. Where does it end? Is it here? No, that's only halfway, huh? It's there, isn't it? That's the end. It starts here, and just focus on this. Forget about everything else. That's all we care about. That's one cycle of sine, right? He starts at 0, up, and then down, and back to 0. He also hits 0 halfway through. So there's one cycle. Use that to find your A and your B. What's A? Oh, he's going down first. Good job. Yeah, he goes down first instead of up first. So that's -4. Good job. I wasn't noticing that at first. -4, huh? Because it goes down first, not up first. Because the normal sign, the regular sign, goes up first, then down. This one's going down. Down first, -4 amplitude. Yes. Oops. So, good. Okay, so -4 sine. Now we got to get the B. How do we get the B? We write that little formula. Period is 2 pi over B. We plug in the period. What is the period on this thing? I mean, just the period. The period's pi over 2. The B will end up being 4, yeah. The period's pi over 2, because that's where it ends. Right, the period is right there. The width of one cycle is pi over 2. So the period, I put in the period side, pi over 2. If you can just look at that and solve by observation, great. Yeah, B's got to be 4, huh? But I'll just do it formally as well. Formally, to solve that, you got to multiply through by the denominator. What's the denominator? 2 and B, huh? See what I mean? Because there's a 2 in this denominator and a B in that one. So you got to get rid of all fractions, you multiply by both 2 and B. You could also just cross multiply there. That'd be real nice too. Either way will work fine. So 2 and B. Whenever we have fractions, guys, you good with that? Guys and gals, you good? Whenever we have fractions, we multiply by the common denominator. That gets rid of them, right? So I got to use 2 and B. So the last one, I only had B in the denominator, so I just multiplied by B. There was nothing in the other denominator. So 2 and B. So B's cancel here, and I get 2 times 2 pi, 4 pi. Getting a little scribbly there, 4 pi. On the other side, 2 cancels 2, and I get B times pi, B pi. Is that good? Last step, how do we solve for B? Just divide by the pi. Once you get rid of the fractions, it's cake. So B is 4. So there we go. -4 sine 4x. That fits that graph. Everybody good with that? How I solve for the B there? Multiply both sides by the denominator. Cancel. Questions? We all good? I move ahead. All right, so let me just do it real quick. So yeah, absolute value just makes everything positive. Whoops. So absolute value makes positive y values only. So it bounces up, right? So notice normally cosine like starts high, comes back. That's the normal. That's normal cosine. But instead, this graph will go, okay, start high, come down, boing. And this part, instead of going down, will then go like this. Wait, did I do that? Like, it's hard for me to do it. Like that, is that right? It'll bounce it up. It doesn't look like any of the graphs they have there.
It's like half of them, half a period.
Yeah, the period's also funny. I'm just talking about the y stuff right now. I don't know. I I can't tell. It's gonna, no, this is right. Yeah, no, what I wrote is right. It's gonna bounce it up. It's not B. It's, and what is the period on this one? The period is 2 pi over B. It's 2 pi. What is B? B is, what's B? Can you tell me? What's B on this graph? B is a half. Right. Does everybody see that? Remember the ABC thing? This is A. B is a half. That's the same thing as a half times x, isn't it? X over 2 is the same as a half x, if that helps you. Right? So B is a half. X over 2 is the same as a half times x. So B is really a half. So it's 2 pi over a half. Flip that up. 2 pi times 2 over 1. 4 pi. So the period is 4 pi. So the period is 4 pi. So it must be D, huh?
No, it's part, I think it's A.
No,
I think
it's
it's
C.
A.
Is it A?
Yeah.
No, it's C. When I did it, because the period was 4 pi, but the right answer was half of that. It was 2 pi.
Maybe you had a different question?
Um,
So in ours, it's got to be A or D. How do you guys know it's A and not D?
When I did this at home,
Oh, yeah, you're right. It's A. It's A. Yeah, you can just tell by the shape of the thing, huh? Yeah, cosine's got to start by going like concave down, like a bowl turned down. See how this one's, well, that one kind of does too. And I don't know, I'm confused.
See, look at mine. I have my question up here with the correct answer.
Okay, yeah, let me check with your particular one afterwards. I'm sure you have a good point, but let me get my act together here. So I can't tell, is it A from D? They both look wrong to me, which means I'm wrong and thinking something wrong. So what am I thinking wrong? I'm thinking the thing should, right here, just bounce up because of the absolute value. Yeah, that's true. Let's make those values positive. The 9 in the front, there's nothing added to it, so the 9 in the front means it starts at 9, goes down to -9, so it'll come back to 9, right, when it bounces. And they're saying it's answer A?